So thank you for coming after the lunch. It's always a difficult spot normally. So I'm going to talk about a network function interconnect fabric, which we call NFIX. So NFIX is the name which we use internally within Nokia, and the goal here is to explain what it means and what we do with it, right? Now, in order to give you a bit of an overview, I think the first thing is to set the stage a little bit of what we are aiming for and what I think NFIX is about. You actually have to know, as a networking person, you always have to, we are interconnecting things, right? And you have to know what is going on around us. So the first thing you have to see is what type of services are actually required going forward for networks to be delivered. And a lot of people talked about 5G, and 5G has kind of three big, let's say, connectivity services aspects. One is, of course, giving more broadband to the end consumer, right? And as such, bandwidth will have to grow, and we have to keep up with that. The second thing is more IoT devices, but IoT is more sessions. I think the big game changer will be what is going to happen to us and to the networks with respect to Industry 4.0 and everything what is related to, in terms of 5G terminology, URLLC, right? Because today, if you look to how we build networks, in most of the time, it's about we look at the bandwidth, we look at where the service is, and we define rather statically. We look at planning, we look at trends, and we basically plan based on bandwidth and to a certain extent, statically latency of how services are delivered into the network. But if you look going forward, we believe that bandwidth is not only the only measure we have to take into account, but latency will become more and more important going forward. Definitely when we look at those Industry 4.0 use cases, if you look to certain extremes, they are talking about a few milliseconds, which is going to be very stringent if you look to what a typical fiber topology is giving you, right? And depending on the countries and the geography, you will see that in certain places, it is much harder to deal with that than in others. And so as such, what will be key from a network is to give service experience, right? Because it ultimately comes down to how the applications, the user, and the things which are actually connected to the network perceiving the service which the network is delivering. And I think our goal is to make sure that that experience is seamless and that experience is the best of all, giving competition also to different carriers. The second thing we have to look at is what is happening around us, because if you are a traditional network or transport person, we used to connect physical elements to things, right? But if you look how workloads are evolving, right? Before we had, let's say, a packet core platform was a physical box, and we connected it with a fiber to the network, right? It was very easy to determine what are the KPIs, what are the SLAs, what are the services which had to be delivered. But if you look on how those workloads evolve, the first thing what you see is they get decomposed, right? So take a packet core today, we talk about cups, we talk about a user plane and a control plane. So it's no longer one thing. It's the same with the Cloud RAN. We have split the baseband unit and the radio unit into multiple pieces, right? And even split it in multiple functions. And this is just a few examples, but there is more of those type of things. Secondly, what you see is that virtualization has, we all have started with virtualization to a certain extent, but you see that the evolution of that is we started with virtual machines. It goes to containers. It goes to containers in virtual machine, maybe containers in bare metal. People are already thinking about it's not a container any longer. It's a function. It's something else, right? So it's no longer touchable. And it can live in different places, potentially, depending on what is the best way to implement that application for the end consumer, right? And that's what we, as a networking, have to interconnect the services towards, right? The third key element is that we talk about automation, we talk about DevOps, because most of us, if you compare us to the public cloud guys, they are much quicker to introduce new things. So people also want to build their next generation network to get things done much quicker, much faster, and introduce new things in a much faster pace than we used to. And as such, software automation are actually very key ingredients going forward to make that happen. Okay? Now, if you look at those three things, then we actually see that it's, if you put it all together, it can be fairly complicated. But I think what we have to do is take a step back and say, okay, how do we make that consumable or implementable, right? Because if we look at all of these things, it can be fairly confusing and fairly complicated for certain people. So as such, what we believe is, if you go back to how we started building networks, and if you look to why the internet is actually so successful, is because principle number one is you decoupled services from transport, right? Services can be implemented on the environment anytime by anyone without too many dependencies, right? I think that's one key principle we have to keep in the back of our mind. The second key principle I think we have to keep in the back of our mind is, and you will see more details going forward, is that it is important to deliver services in such a way that you only touch what we call the edge and do not configure or touch or deal with anything into the middle, right? So as such, when we looked at IETF definition, we came up with the terminology of a PE and a P, right? And today, if we configure IPVPNs or EVPNs or E-lines or E3s and all of that stuff, we configure the PEs, but we do not touch the core. And I think it's a key principle we have to keep into the back of our mind, because this is a capability which allows us to do things much faster and much quicker. And if we can succeed that in a heterogeneous world, where workloads are both physical, virtual, containers, function, and what have you, I think we have a compelling case. Okay? Now, the next question you have to ask these days is, what is an edge? Right? Because before, as I said, a PE was a physical box, and you knew you could touch it, and you could configure it, and you could define it. But if you look going forward, what is an edge in the future, or actually even today already, it can be either a physical element, and that could be a peering router or a real physical router, or it can be a leaf switch in the data center, right? Because we have still hosted services, so you can actually have a top-of-rack switch or what have you. But you can also have virtual functions, right? So if you look to the extreme, it can be a user plane, which is a virtual thing, or it can be even, in some cases, a virtual switch, which is either implemented on a server or on a NIC, or maybe in going forward on an FPGA, which is sitting somewhere. So as such, you see that an edge by itself is no longer one thing which we know about from the past. It's no longer a PE, which is a physical device. It can be multiple things depending what you do and how you connect your services. Now, the third question you then have to ask, where is the edge, right? Because in the past, we had very key physical boundaries of where things were delivered, right? We had central, let's say, edge service points, and we were connecting there. But you will see clearly that depending on use cases, and I think the key driver will be this ultra-low latency type of use cases, which will potentially distribute that location much further into the network. Now, and of course, distribution is sometimes required, and this is an example of a use case which we have done, and given that we are a Finnish company, we took a Finnish example, where you see that sometimes at distribution, you have to distribute application and user plane together to increase the latency, right? Because if you do only one and not the other, you don't get the right example. But what is key is that depending on your use cases and your services your network actually has to deliver, you probably end up with some level of distribution you'll end up doing. And as such, that's why we are talking about mobile edge clouds, mobile edge computing, and so on and so forth. So if you look at how you build a network for the future and how you build a network for 5G or for any other services we talk about, we have to also take that piece into account. Okay? Now, given all of that, let's look at the network. And I try to depict probably, and there will be other examples which you have, but I try to depict how a network looks like these days in most of our cases. Is you have access, you have an aggregation. I try to put an edge cloud there, which is probably sitting in between, depending on the geography, can be sitting somewhere else. You have a core, and you have central services distribution points where you have, I depicted central data centers. Now, if you want to deliver what I said before, and if you segment these pieces in different chunks, it's not going to be easy, right? Because delivering a service which consists of physical and virtual function, if you have to touch all the elements in the middle, which is depicted here, and this is probably a very easy representation of the reality, it is not easy, right? The second thing what you have to take into account, this morning we talked a lot about AI, self-driving, self-optimizing, and what have you. The more things you have to touch in the middle to achieve your results, the more difficult it's going to be. Okay? And as a result, or that's why I said from the beginning, taking into account principle number 2 is touch the edge and not the middle, is one of the key principles we believe we have to take into account in the architecture going forward on how we build networks. So to introduce you NFIX, what it actually is trying to do is what I try to depict in the picture here. So we try to abstract the interconnectivity points in between those different elements. And I'm not saying you have to collapse all those networks in one big thing. You can still operate them in their separate IaaS instances or their separate AS and what have you. So we don't change that. But what we do is we ensure that you have the capability to provide a seamless connectivity between any endpoint, whether it sits in a data center, either distributed or centralized. And it can talk to either virtual functions or physical functions. It shouldn't matter. But the key goal is you touch the endpoint where your services are connected, and only that is what you configure. And by using then segment routing, which we'll talk in a bit, you have the ability to instruct the network to comply to certain KPIs or which actually the services is dependent upon, right? And then by giving central control, you have the ability to actually understand what's going on and can do global optimization depending on the service requirements your typical application have, right? To put it into a different thing and abstract it even more, right? What we are actually talking about is the following. There is 2 key ingredients. Ingredient number 1 is we build a fabric consisting of from cell side or backhaul where your base station or your accesses are connected to, all the way up to any data center, whether it's distributed or central, or your physical peering points as such, right? So that is what we call the fabric, okay? And the fabric represents itself through a single API to actually make sure that we abstract that whole underlying infrastructure on how that network is constructed. We simplify and abstract that to the higher layers. And that API or that element is basically collecting information from the network, it's collecting telemetry, it's having the configuration state, it has different type of information, and by giving him that information, it can actually do things with it, depending on your requirement or what you try to achieve from an application perspective and what type of business model you have in mind. To go to the detail, and it's probably the most technical slide which I have, is how do we do this, right? Because it's all nice and shiny, it looks maybe good in the theory, is that the way we go about this is the following, is we started with seamless MPLS, I believe 7-8 years ago, if I came back in time, and what did we do with seamless MPLS? We actually tried to achieve the same thing. We had aggregation network, we had core network, we had other aggregation networks, and what was our objective is how do I deliver a service between aggregation and core or aggregation and aggregation without touching the things in the middle, okay? Now, when we did that, we were, at that time, mainly focused on that ease of operation, and the service creation, right? In the meantime, we talk about latency optimization, we talk about diverse paths, so all the traffic engineering type of tool sets, we didn't have requirements for at that time. But if you look to the new service suites which are coming along, we need to take into account all of these type of things. So that means we need to ensure that we can define the minimum latency to come from point A to B across those heterogeneous networks, right? The second thing, at the time we defined seamless MPLS, we did not have data center or virtualization or NFV. We were not even talking about that at that time, right? So you see that service chaining was not even at the table. So you see that we have to enhance seamless MPLS with a number of capabilities to achieve that objective. And what are those capabilities which we believe are important to add? One is segment routing, and even bringing segment routing inside of the data center. And the flavor on how to do that can be different ones, right? Because there is different flavors. You can do segment routing either with MPLS, you can do it over UDP if you are trying to mimic VXLAN. We are also not saying that VXLAN, which has been done today, you have to replace, but you only introduce this for your north-south traffic, not for your east-west. You can stay with VXLAN there. But then what you do is, when you have segment routing as a capability, you have the ability to instruct the network and define the SLAs which you want across those heterogeneous points. And then by giving the right configuration state and so on and so forth, you can actually then do optimization, look at what is happening into the network, and trying to optimize it. Okay? So some use cases of that are, first one is, of course, service creation, right? So the first thing what you try to do is instantiate services between, as I said, physical or virtual endpoints, or maybe virtual, and you have all these combinations. We don't really care, right? The second use case is going into more self-driving, if you will, which is you actually collect information of the network rather than using routing information and saying this is the best effort path. You actually use information from the network which you collect through telemetry information, and you can say, this latency is changed. I will rewrite my traffic to another path, right? And you can do that either completely dynamic, if you will, or you can give that information as a visibility and then have someone act upon it, right? So you can go into full automation mode or in semi-automation mode. Third type of capability is by the fact that when you collect all of this data, you can actually, as again discussed this morning, use machine learning and AI to look at what happened in the past, what is happening today, and what is happening in the future. So you can actually do predictions going forward on what is going to happen based on that data, because by collecting that information, you can actually, depending on the type of schemas and algorithms you use, you can actually do potentially some prediction going forward on operational or services use cases. So, to conclude, the way you have to look at SD1, at Hendrickx, is think of it as what SD1 does for overlays, right? So SD1 is actually doing exactly the same thing. The only thing it says, I don't understand or I don't want to deal with the underlay, right? I build overlays, I measure the latency end to end. Hendrickx is doing the same thing, but actually focused on an environment where you own the network and where you are the owner of the network. And what we are trying to do is make that service experience seamless and trying to help giving you insight and optimize that, right? The second thing what you have to take away is that it's not revolution, right? As I mentioned, we come from seamless MPLS. By upgrading your installed base, you are probably seamlessly going to get to this. And it's not a Nokia-only thing, because everything which we do in here is fully using standardized routing protocols. And for those who are really interested and want to go into a much more deeper dive, I would invite people to come to our booth, because it's actually real and it's working today in a number of the use cases which we have, which we can show to you at the booth. So with that, I would like to thank you.